So there's another definition of the integral, which is known as the definite integral. Which is defined in a way which originally will seem quite different, but as the name suggests, is closely related to the indefinite integral. So, the definite integral is defined in terms of area. In particular, the definite integral of some function f of x from a to b, where a and b are two real numbers, is given by the area under the graph of f of x between a and b. Okay, so that's the definition in words. This definition is really much clearer in a picture. Suppose that I've got some function f of x, looks something like this, and I give you 2 points, a and b. Here, the integral between a and b is given by the area here. So this area here, I can write as a and b, so the area between a and b, and this is the definite integral. Okay. So again, there's a note and some notation. So I'll do the notation first in this case. So again, you've probably seen this already. You write this definite integral, this area function, a of a and b, as integral a b f of x dx. Okay, so the notation is very similar to what we saw for the indefinite integral, but remember these represent different things. The indefinite integral is the function you need to differentiate to get back f of x, whereas the definite integral is defined as the area under the curve here. Okay. So an important thing to note is what happens when the function f of x is negative. So if f of x is less than 0, then the area is counted as negative 2. So the area is counted as negative. Okay, so again, I think this is most clearly explained on a picture. Suppose I've got a function f of x again, but this function now has both positive and negative values, f of x, and I choose some points, b here, a here, then the area here, this part, is counted positive, but the area down here, this part, is counted negative. So therefore, if I call this one area number 1, and I call this one area number 2, can you see that okay? Maybe. Then the integral, the area from a to b of f of x dx is defined as equal to the area number 1 minus the area number 2. Okay? In other words, the area where f is negative is counted with a minus sign. Okay, so that now defines for you the definite integral. Now, why are these two concepts connected? So why is the definite integral connected to the inverse derivative, the indefinite integral? So the easiest way to see this is just to answer the question. So answer the question, what is the derivative with respect to x of the definite integral, that's the area, between a and x? Okay, so let's see this on a graph. Here's x, and again I'm going to do a function, something like this, okay, and we go up to x, let's say here. So how is the derivative defined? This thing is equal to the limit delta x goes to 0 of a x plus delta x minus a of ax divided by delta x. That's the definition of a derivative, right? And this a of ax plus delta x is the total area from a, which can be somewhere down here, up to x plus delta x, which I can say is here, x plus delta x here, okay? So this first term is the area up to this line here. This second term is the area up to x, that's the area up to there. So therefore the difference between them is just the area of this part here. Okay, so this part here is a of ax plus delta x minus ax. Okay, but you can see that if delta x is very small, as we take the limit delta x goes to 0 and the derivative, this area is going to be approximately equal to the area of this rectangle here, right? And this rectangle, the width is delta x. The width here is delta x. The height here is f of x. So therefore this area here is going to be approximately equal to f of x times delta x. Okay. So therefore you see that d by dx of ax is equal to the difference here, which we've said is f of x times delta x divided by delta x, which is equal to f of x. Okay, so what does this mean? This means that the derivative of the area function is equal to the function that you are integrating. In other words, the area function, a of a and x, is itself an indefinite integral. In other words, you differentiate it, you get the function f of x. Okay, so this result is known as the fundamental theorem of calculus. So let me just state it clearly, and yeah, then we'll finish this video. So what we've shown is that the derivative of the area function is equal to the function f of x. So what this means is that this definite integral is also an indefinite integral. Of f of x. Okay. So they are related, and we can be a bit more specific. If we have that the integral of f of x dx is equal to f of x plus c, okay, and we know that this is equal to the area function a from a to x, then first of all, if I put x equals a here, then we get f of a plus c equals a, and a. But this means the area between a and a, which is 0. Right? So in other words, the constant c is just minus the indefinite integral at a. Also, if we take x and replace it with b, then this tells you that f of b plus c is equal to the area from a to b, which we've seen is written integral a to b f of x dx. But we've shown that c is equal to minus f of a. So putting all this together, you get the integral from a to b f of x dx is equal to the indefinite integral f at the point B minus the indefinite integral f at the point A. And this result is known as the Fundamental Theorem of Calculus. And what does it do? It relates the two different definitions of integral we've seen. On this side you've got the indefinite integral. Big F is just any function whose derivative is small f. And on the left-hand side here, you've got the area under the curve of f of x between a and b. So therefore, this result relates the definition of integral in terms of area to the definition of integral as the reverse derivative. Okay, so finally, this is really finally, because we had the results of the product rule and the chain rule for the indefinite integral, you also get equivalents of those for the definite integral. So let me just state what those are. So the first one was the product rule, which, as we said, is called integration by parts. Okay, so as I wrote it down before, this is the integral of, how did I write it down before? The integral of f of x g prime of x dx is equal to f of x g of x minus the integral of g prime of x, minus the integral of f prime of x g of x dx plus c. So that was the form we had it before as an indefinite integral. As a definite integral, you just put the limits a and b on here. So f of x between this. But here, using this result here, you have to evaluate it first at b and then subtract the value at a. So what you get here is f of b g of b minus f of a g of a. So that turns into this, and then finally minus the integral from a to b of f prime of x g of x dx. Okay. So this is the definite integral form of the integration by parts formula. Okay, and this here, this term in the middle where you evaluate it at b and a, is often written as follows: f of x g of x in square brackets with a b at the top and a at the bottom. So what this means is take this function, evaluate it at b, and then minus the result at a. Okay, so that's the integration by parts formula. Secondly, you get the integration by substitution, formula 2. So remember, the formula as I wrote it for the indefinite integral was that the integral of f of x dx is equal to the integral of f of x of u times dx by du. So that was the indefinite form. So as a definite integral, again, you just put the limits on. But you need to be a bit careful. Here the integral is with respect to x, and x goes from a to b. But here you're integrating over u, so therefore the limits of the integral here are not just a and b, but they're rather the value of u when x equals a and the value of u when x equals b. Okay, then the rest is unchanged. So this is quite a common mistake, by the way, so I will stress it. A lot of students, when they make an integration by substitution of a definite integral, forget to change the limits of the integral, but it's absolutely essential that you do so. So here x is going between a and b, so here you need to change it to the values of u when x equals a, and the values of u when x equals b.